Data visualization is the cornerstone of successful machine learning projects. Every major breakthrough, from Netflix's recommendation system to autonomous vehicles, begins with understanding data through visualization. Today we'll master Matplotlib, the tool that transforms raw data into powerful insights that drive million-dollar decisions. Think of data visualization as detective work with a magnifying glass. Raw data resembles a crime scene with thousands of scattered clues, overwhelming and confusing. The right visualization organizes these clues like an evidence board, making patterns jump out instantly and revealing insights your brain can process in seconds rather than hours. Before training any machine learning model, visualization answers critical questions about your dataset. You need to understand relationships between variables, identify outliers that could skew results, assess data sufficiency, and spot patterns that inform feature engineering. These insights are impossible to gain from raw numbers alone. Matplotlib's architecture centers on two fundamental components, the figure and axis. The figure serves as your canvas, the overall container for your visualization. The axes represent the actual plot area where your data lives, including the coordinate system, tick marks, and labels. This simple but powerful design allows for both quick plotting and sophisticated customizations. Every machine learning practitioner must master four fundamental plot types. Line plots reveal trends over time, perfect for monitoring model training progress. Scatter plots explore relationships between variables, essential for feature correlation analysis. Histograms show data distributions, crucial for understanding data pre-processing needs. Bar charts display categorical data, vital for class balance assessment. Line plots excel at displaying continuous data and temporal trends using the PLT plot function. In machine learning contexts, they're indispensable for visualizing training curves, showing how model accuracy or loss changes over epochs. They help identify overfitting, convergence issues, and optimal stopping points during model training. Scatter plots utilize PLT scatter to explore relationships between two continuous variables, making them perfect for correlation analysis. They instantly reveal linear or nonlinear relationships, help identify outliers that might affect model performance, and guide feature selection decisions. The visual pattern immediately shows whether variables are positively correlated, negatively correlated, or independent. Histograms use PLT hist to display the frequency distribution of numerical data, revealing the underlying statistical properties of your dataset. They help determine if data follows a normal distribution, identify skewness that might require transformation, and spot multimodal distributions that could indicate multiple underlying populations. This information is crucial for choosing appropriate machine learning algorithms. Bar charts leverage PLT.bar to display categorical data frequencies, making them essential for classification problems. They instantly reveal class imbalances that could bias model training, show the distribution of categorical features, and help assess whether you need techniques like SMOT or class weighting to handle imbalanced datasets. The tight_layout function automatically adjusts spacing between subplots to prevent overlap and ensure readability. This is crucial when displaying multiple plots simultaneously. The show function renders the complete visualization, displaying all four plots in an organized, professional layout that's ready for presentation or analysis. Successful machine learning projects always begin with thorough data visualization before any modeling attempts. Choose plot types that match your data characteristics and research questions. Use visualizations to validate statistical assumptions required by your chosen algorithms and identify outliers that could severely impact model performance. Tomorrow we dive into NumPy arrays, the computational engine that powers every machine learning calculation. You'll learn how these optimized data structures enable efficient numerical operations, serve as building blocks for popular ML libraries like scikit-learn and TensorFlow, and form the foundation for implementing algorithms from scratch. This knowledge is essential for understanding how modern ML frameworks operate under the hood.